Hey guys, I'm CG Smoothie and welcome back to another video in the quick intro series. In this series, I give a quick rundown on almost everything there is to know about a certain topic so you can use that topic in your projects. In this video, we'll be doing a quick intro to C#, or in this case, more specifically, the variables and functions you will most often have to use when coding in C# for Unity game development. If you guys find this video useful, please let me know by leaving a like, subscribing, and letting me know in the comments, especially if you want a more in-depth C# tutorials for things such as vector 3s, quaternions, and whatnot. If you're doing this in Unity and want to follow along, I'm just making an empty game object with a brand new script on it. Without further ado, let's get right into this. So variables. Variables are the quick way to store data values and objects that you use repeatedly throughout code. To define these, you state the variable, a defined variable name, and then its value on the right. So the first type of variable is an int. This is a value that stores integers or whole numbers without any decimals. So you could use this for like speed or whatever. So int speed equals 5. The next variable is the float. It's also called a double, and floats can store any number, even ones with decimals. They take up a bit more storage space than ints though, so know when to use both. This would also be used for like speed, but it can use decimals, so... And when you use a decimal, you have to put f at the end of it. So there you go, like 7.5f. The next variable is a character. It is able to store any keyboard character such as numbers or letters or special characters. To define it in code, make sure to put it in single quotes. So there you go. That's how you would define a letter. Also, most common syntax is you define your names with the first letter of each word, except for the first word capitalized. The first word is not capitalized. The next variable is string. Strings store an ordered combination or string of characters in a row. To define this in code, make sure to put them in double quotes. So string word equals double quote, hallelujah. The last basic variable is a boolean. This stores a true or false variable. It will, like, if you want to find out if you are touching ground or if there's something in your way, that's what you would want to know. And you define it with true or false. Then, we also have lists and arrays. So, they are essentially the same. They do have differences, but that should be a different tutorial. Essentially, they do the exact same thing most of the time. They store multiple of any variable, such as an entire array of ints or an entire list of strings. To define an array, you want to state the variable that is in the array, brackets to represent that it's an array, so like int bracket integers equals, and then you would say on the right side, new int bracket, and then in curly brackets, you would define all the terms. So, like 1, 4, 3, 2, and then blah. So you can also assign or change the values to these variables through code within functions such as start or update. So like at the beginning of start, you could say speed equals 7. You can also do that in update, but we will go over the functions in a couple minutes. It's also important to keep in mind whether or not your variables are public or private. If they're private, other variables cannot see them. If they don't have an identifier before them, they are all private. They're not public until you put public in front of it. In the case of Unity, if they're private, you cannot see them inside the editor. So like if I save this right now and go into my Unity project, you can see the only thing you can see is speed, because that is the only public variable right now. If they're public, you can change them within the Unity editor, and any script can reference them as long as that script also references the specific instance of the script you're using, unless we use the next thing we're going to talk about, static. Static values are values that do not change regardless of the scene you are in, but they can still be changed in code and whatnot. So, like, if we put static bool real in a different script within this project, like here, you also have to make sure it is public. So you can see, you can add that to a different script without any problems. But if I didn't have static here, if I take that out, you cannot reference it. So make sure if you're going to reference it in another script and it doesn't change, you would want to put static in front of it. Static values are values that do not change regardless of the scene you are in, but they can still be changed in code. Things that you would want to keep static are things like player health, music and audio volume, and what kinds of checkpoints or bosses they've cleared. Important to note that static values by default can also not be seen within the editor. Like, even though it is public, we cannot see it in our thing here. Specific Unity classes are variables specific to Unity that can only be used using the Unity engine directory right here. When you add more directories, you can use more variables from UI or other Unity packages like Cinemachine or A-Star, a bunch of packages. Specific Unity classes include GameObjects or transforms. These are game objects you have within your scenes, like the player or enemies or whatever. A game object is the thing that has all the components, while a transform contains the position data and child objects. You can also use the GameObject class to reference its transform by stating the GameObject's name and then adding .transform to the end. Important to note that GameObject and GameObject are two completely different things. This kind of GameObject references any GameObject in the scene, but this GameObject references the GameObject that this script is connected to. So like, if I did debug.log GameObject, it would say that. But if I then put GameObject spaceship public, and then added this spaceship here, and I changed this to say debug.log spaceship, it would say the spaceship right here. Okay, scripts and components. Scripts are usually components on top of GameObjects. Components include things such as rigid bodies, colliders, movement scripts, and a lot more. You can reference these by dragging and dropping the specific scripts from the editor into your script, or by referencing the GameObject that had these attached to them and using the getComponent function to link it. So, like here, if I wanted to get the spaceship movement script, I could do public spaceship movement, SM, and then just drag and drop the spaceship here, and you get that script. Or you can put SM equals spaceship dot getComponent spaceship movement, parentheses, dot, yeah, there you go. And then in here, if we deleted this on start, it would add it to here. Functions. Functions are the way within the script to manipulate variables during runtime at a specific time, such as at the first frame of the game, or when the object with the script on it is created, or on every single frame of the game. So some very common functions are start. This is called before the first frame update, as long as the script component is enabled. But awake is called before that, regardless of whether or not the script component is enabled. So if I turn this to awake and disabled, or if, let's just keep it as start right now, disabled it, on start, it would not debug.log anything here. But if I made that say awake, it does it regardless. You can still see it debug.log here. Alright. Update is called every frame as long as the script component is enabled. So if I just said debug.log hi in quotes because it's a string, it would say it every single frame. You can see it's just gonna, oh, it's not enabled, but now it just says hi over and over and over again. You can see there's so many highs. But FixedUpdate is a different one, and this does on every physics update. This is, you want to do all your physics work in FixedUpdate, not update, because if you use update for physics calculations, you will get different results depending on the frame rates. Unless you put time.delta time, but that becomes annoying. So I would recommend on every physics calculation, you use this function. Like if you're adding velocity or force to a rigid body, you want to use FixedUpdate, not update. Those are the basic functions, but another helpful one that I use a lot for Unity specifically is OnEnable. This helps with if you turn off the script component in another script somewhere else, it will call whenever the script component itself is enabled, as well as the start as long as it's enabled. So it's like start, but it works on every single time. let's go back to if this was start. You can see it only works on the first frame. Even if I disable it and turn it back on, it doesn't debug.log again. But if I change this to OnEnable, you'll see that it does it every single time I disable and enable it. So it's good to keep in mind that there are more basic functions. Finally, you can create your own functions. Like, if I wanted to create a script to calculate the average of all the ints in this integers array, I can make a new function called void calculate mean. You also always have to put void before your functions. And public also does the same thing. You can reference calculate mean in here if I put public in it. So I can, inside the parentheses, you can establish parameters. Like if I add integer array numbers, then I can, in OnEnable, put calculate mean here, and then integers, and there you go. That says that it calculates a mean from these integers, but I can also do it from a second int array here. If I just like go here, and it's a completely different array, and I can do the same thing with integers 2 and calculate the mean for that too. And you can do that for as many times because custom functions get rid of reused code, so you can just have one void instead of having to write the same code over and over again. So I can set a function here to calculate the mean of all these numbers. So I would just make float sum of all numbers equals 0 for each int number in numbers sum of all numbers plus equals number. Float mean of all numbers equals sum of all numbers divided by numbers dot length, and then debug dot log mean of all numbers. And then you can see, just go here and it calculates the mean here. Functions can actually be called within other functions, which is why we would create another function, especially if we had to calculate this mean a couple times throughout our script. Then we would just put calculate mean in the start function, and we would run our script. It would tell you the mean of all the numbers in our array. Remember to put the parentheses when you call a function, which is why you have to put the parameter in here. I hope you guys enjoyed this quick tutorial for basic C# variables and functions. Again, if you want more in-depth tutorials like for that for each loop I have in the calculate mean function, let me know in the comments and I will be sure to make that. If you need more specific help with C# coding, I have a thriving Discord with almost 100 members at this point, and we can all help each other out with our various coding qualms. If you did enjoy it, check out these other videos YouTube thinks you'll like. With that, I'll see you guys next time. Bye!